Perhaps it's interesting to show the progress on the shortwave radio oscillator that I was working on during the past days. It will be used perhaps in a superhet going from 10 megahertz up to approximately 20 megahertz. It is now more or less definite, but of course you need for such an oscillator, any oscillator, a stabilized voltage, at least when you want to use it to tune to certain radio stations, and that's the aim of the whole idea. I don't know if it will succeed, but anyway. The name of this video is Mini Classical Voltage Stabilizer. And this is what it is. There are a lot of these videos on my YouTube channel regarding this circuit. But anyway, perhaps it's interesting to pay some attention to that circuit. And in this case I've used the BD139. That's an NPN silicon transistor with an amplification factor in the order of 70 up to 150. When they are out of China, could be that you even see a higher current amplification than 150. Doesn't have to be a problem in general, but it also means that a circuit can get more critical. By the way, I've used here also such a Chinese BD139, and it's a classical series regulator. When you want to know more, go to the World Wide Web, Google, etc., etc. Type the keyword series regulator and you will find everything, or perhaps not everything, but anyway a lot of info about how this works. Whole principle is very simple. We hold the voltage on the base of such a series transistor constant. That means that even when at the input the voltage changes up to whatever voltage, the output voltage is the same, because the Zener diode gives it a fixed output voltage, and there is a voltage drop in the order of 0.7 volts. That's important in this circuit. You can fine tune here the output voltage with the help of normal silicon diodes, but they must be reversed in the row. So you can see it here. And by the way, this capacitor here, 10 microfarad, is in a certain way amplified. It's a kind of Miller circuit, and when we talk about, say, the hum suppression, 10 microfarad amplified by the current amplification here, say it's 100, then we have here at the output an effective electrolytic or whatever, electrolytic, say 150 multiplied by 10 microfarad. Anyway, that's in a certain way not the aim of my video now, but anyway, I needed for this oscillator a voltage of 15 volts. That worked best, and when you are interested, I can show the schematic of that radio oscillator anew with all the adaptations. Here a 100 ohm resistor added. Here a 100 kilo ohm potentiometer added to tune in. And here a 220 kilo ohm fixed value resistor, and also here in the bias of the schematic there was already in the original schematic here this 1 kilo ohm fixed value resistor, and now I added here also another 1 kilo ohm. Anyway, it worked nice around 13 megahertz, 15 megahertz, 18 megahertz, but of course I have to study the coil here extensively, how it all must be made. Anyway, let's go back to the very simple mini classical voltage stabilizer that's here. And I told that you can say align the output voltage with the help of normal silicium diodes. Let me demonstrate that. At the moment the circuit works on, say, 20 volts. Now going to 25 volts. This is the output voltage, by the way, 14.7. And now I'm going to the maximum voltage that I can give to this mini classical voltage stabilizer. And it's made, like I always do that, with brass nails on a piece of well varnished dry wood here. So that's not a kind of idiot way of making electronic circuits. Anyway, I got some comments in the past about it. What's the use of making these circuits all with brass nails on wood, etc, etc. But anyway, 14.8 volt here at the maximum of my power supply. Let's go back to 20 volts, that will be more normal, and we see tiny difference here. I think it's stable enough to drive a high frequency oscillator. That's here. Well, I only wanted to demonstrate the effect of, say, series normal silicium, normal silicon silicium diodes in that row. So I'm going to shortcut one of them now. Here, you can see it here. I shortcut one of them. Let's look at the output voltage. So here one is shortcutted, and you directly see that the voltage drops back. I open it again so that the diode works again, and it means that with, say, the help of a few normal silicon diodes here, 40.07, 40.7, each silicon diode gives a voltage drop in the order of 0.7 volts. So you can align, fine-tune to the exact voltage that you need for a certain electronic application here. Anyway, thanks for watching. Don't want to make this video too long. Though all these principles are very simple. And they work. That's the most important thing.